In order to find the mean and standard deviation of this probability distribution, we have to basically create a table that has x and p of x listed in a vertical fashion. So we'll end up having 0, 1, and 4 for x, and 1/3 for each of the probabilities. Then, to get the mean, we're going to do x times p of x. So, in order to do x times p of x, is 0 times 1/3, which is 0, 1 times 1/3, which is 1/3, and 4 times 1/3, which is just 4/3. Now, from there, we need to calculate x squared times p of x. So x squared times p of x basically involves us squaring the x's and then multiplying times p of x. So if you square the x's first, let's do that over here on the left. We'll have 0, 1, and 16. And then it'll be 0 times 1/3 for the first one, which is 0. Then 1 times 1/3, which is 1/3. And then 16 times 1/3, which ends up giving you 16/3. All right, from here we need to total these two positions. So let's do that. If we add 0, 1/3, and 4/3, we get 5/3. And that is the mean, right? Because remember, the mean is equal to the sum of x times p of x. That was the definition we used in chapter 4. For x squared times p of x, we're going to sum that. If we add 1/3 to 16/3, we get 17/3. Now, this is the sum of x squared times p of x. We can then use that value to come up with the standard deviation. The standard deviation, by definition, is equal to the square root of the sum of x squared times p of x minus the mean squared. Now, this quantity is nothing more than 17/3. We just discovered that. So that will be 17/3 minus the mean squared. We said the mean was 5/3. If you square 5/3, you square the top and the bottom, so you end up with 25/9. Okay, so then it's just a matter of combining these two fractions and then taking the square root. So if I rewrite 17/3 so that it has a 9 in the denominator, that will be multiplying the bottom by 3 to give me 9, and the top by 3 to give me 51. So 51 minus 25/9 is the arithmetic there, and then of course you end up getting 25 taken away from 51 will give you 26, and it'll be 26/9. And then from there you simply take the square root, and that will give you approximately 1.6997. Okay, so that's your standard deviation, you have your mean, and that's the answer for part A. All right, for the next phase of this problem, they're asking us to find the sampling distribution for the sample mean for a random sample of n equals 2 elements. So what you actually have to do if you're going to do this by hand is you have to think about all of the possible outcomes that could occur if n is equal to 2 and you're calculating the mean of the values that were selected. So what you're thinking about is just thinking about what could you grab. If there was a bag of these x's, the x's are 0, 1, and 4. If you had a big bag of them and you were reaching in and pulling them out, what would you get? You could possibly get a 0 and a 0, right, on your two selections. So you get 0 and 0. And if you added those together, 0 plus 0 is equal to 0. And if you divide it by 2, which is the size of your sample, the x bar in that case will end up being equal just to 0. So that would be your first possible outcome that could occur, right? Now, from here, that gives you an outcome, right? It gives you an outcome, but from the outcome, we can also talk about the probability that that would occur. It says the probability that we grab a 0 from the original, say, bag of x's is 1/3. So the chance that we grab that first 0 is 1/3. The chance that we grab the second one is 1/3. Since there are two events, we multiply the probability of getting each of those to end up with the probability of 1/9. So the probability that we would grab a 2 zeros from the bag of numbers is 1/9. So what this gives us is an outcome and a corresponding probability. So you could begin to create a table now. You could say, well, the possible x bar values that could occur are 0 for one thing. That could be one x bar value. We just saw how that would happen. That would be if you got 2 zeros in your selection. Then the probability of that outcome, right? So the probability that you would get that x bar is 1/9, and we calculated that. Okay, now in order to consider the next possible outcome, think about what else could happen. Well, you could grab a 0 from the bag, and then you could grab a 1, right? That's something that could occur. So if you grab the 0 and a 1 on your two selections, remember n equals 2, so we're taking two items, so you could get a 0 and a 1. If that were to occur, then the sum of these two values would be 0 plus 1, which is 1. And then if we divided by our sample size of 2, the x bar in this case would be equal to 1/2. And now we'd have to work out the probability of that. So we know the outcome is possibly 1/2 or 0.5. And then the question is, what's the corresponding probability? Well, the probability you get a 0 is, again, 1/3. The probability that you get a 1 is also 1/3, right? Now, you may say, oh, well, then the answer is 1/9 again. But you have to be careful because there are two ways to get 0 and 1. You could also get 1, 0. That's a different outcome because the 1 comes first, whereas in the last scenario we described, the 1 comes second. So there's two ways to do this. You can either get a sum of 1 and therefore a mean of 1/2, either this way or this way. Now the word or means to add in probability, if you remember. So we're going to have to do plus the probability that it's a 1 on the first draw, which is 1/3, times the probability that it's a 0, which is 1/3. Remember where I'm getting these probabilities from. They're coming from the original distribution over here, right? We know that 1 has a 1/3 chance, 0 has a 1/3 chance, and 4 has a 1/3 chance. All right, so if that's true, then what we're saying here is that it's going to be 1/9 plus 1/9, or in other words, 1/9 plus 1/9 gives you 2/9. So the chance that you get 1/2 as an outcome is 2/9. Okay, so I'm only going to do one more of these just to kind of, show again how this is done. So let's just do one more case. Let's imagine the scenario where you end up getting 0 and 4. So if you have the scenario of 0 and 4 taken, so if 0 and 4 show up, that can occur in two ways. Either you can get 0, 4, or you can get 4, 0. And the sum in that case would be 4, right? So x bar would end up being 4 over 2, or in other words, 2. So your next sample mean in the list could be 2. You could also, if you wanted to, put them in numerical order, the sample means. It doesn't really matter, but if you want to leave a space, we can put 2 here because it is possible to get 1. Either way, let's go ahead and put 2 there in our table, and the order doesn't really matter. You could always reorder it later, but the point is that x bar of 2 is possible. If you got 0 and 4 as a selection, or 4 and 0, the sum of those two numbers is, of course, 4, and then you divide by 2 your sample size, you end up with a sample mean of 2. Now, what's the probability? Well, remember, each one has a 1/3 chance, right, of occurring, but the word or means to add, so you have two ways you can get this. And again, that means that there is, again, in this particular case, a 2/9 probability of ending up with a sample mean of 2. All right, I said I would only do one more, but let's fill in the case where it's 1. How do you end up getting 1 as a total? All right, so I said I would only fill in one more, but let's do one more case anyways. So let's do 1. How is the possibility that you get 1? Well, you could grab a 1 on the first selection and a 1 on the second selection. And there's really no way to rewrite that because, saying you get a 1 or a 1 is the same as before, right? Since 1 would be the outcome for both selections, you really can't reverse the order and say it's different. It would be the same experience. In both cases, both selections end up being a 1. So there's only one way to do that. And if you do that, of course, 1 plus 1 makes 2. This means the x bar would be equal to 2 divided by 2, which is 1. And that's why we'd have a 1 here. And of course, you think about the way this can occur. There's a 1/3 chance it turns out to be a 1, another 1/3 chance it turns out to be a 1, and that gives you 1/9 as a probability. So it'll be 1/9 here for this space. And then so on and so forth. You keep doing this until you list all the possible outcomes. All right, so basically from here, you should be able to figure out the remaining cases. If you think about what we've done so far, we did the scenario where you grab 0 and 0. We did the scenario where you grab 0 and 1. We did the scenario where you grab 0 and 4. We worked out the scenario where you grab 1 and 1. Then you do the scenario where it's 1 and 4. And then you'd have to work out the scenario where it's 4 and 4. Okay, and that will cover the different cases, the 6 different cases. Remember, you can do some of these in 2 orders, some of them only in 1 order, right? Like these only occur in one way because they have the same value. But for each of these guys, there'll be 2 ways you can get it. You can get 0, 1 or 1, 0. 0, 4 or 4, 0, 1, 4 or 4, 1. If you work out the remaining cases, you'll be able to fill in the rest of this table. All right, the last question this problem asks us to do is to show that x bar is an unbiased estimate of mu. So we already saw that the mean for the original distribution up here was 5/3. In order to show that x bar is an unbiased estimator of mu, we have to show that the average value for x bar, or in other words, the expected value of x bar, which remember is just the average of x bar, is equal to mu, which is supposed to be 5/3. The question is, can we show that the average value for x bar is 5/3? Well, I think we can. Remember, all we need to do is do x times p of x and then add those values together. So let's go ahead and do that here. If we add another row to this column, just do x bar times p of x bar. What you can do then is say, okay, what's 0 times 1/9? That'll be 0. What's a half times 2/9? That's going to be 1/2 times 2/9. You can see that those will cancel out, just giving you 1/9, right? So we'll just say that this is 1/9. And 1 times 1/9 is 1/9. And you'll have 2 times 2/9, that's 4/9. Then you'll have 2.5, or in other words, 5 halves, is another way to write 2 halves, times 2/9 means you can cancel out the 2's. You'll end up with 5/9 there. And then lastly, you have 4 times 1/9, which is 4/9. All right, and then if you want to add all these together, that will give you the mean, right? The mean is the sum of all of those things. It's the sum of x times, or x bar in this case, times p of x bar. That's how we learn to do the mean for these probability distributions. So you just add these values together. Since they all have 9 as a denominator, we'll keep the common denominator of 9. We'll add 1/9 to 1/9 to 4/9 to 5/9 to 4. And if you add up all those numerators, you end up with 15/9. And of course, 15/9 can be reduced. 3 can go into the top 5 times, while it goes into the bottom 3 times. You end up with 5/3, which is what we needed to show in order to be able to show that the mean for x bar is the same as the mean for x, the same as the mean for the original distribution. And what that means is that the expected value of x bar is equal to the population mean, and that would show that the estimator x bar is an unbiased estimator of mu.